Hi. Now, product and quotient rules. A common misconception is that derivative of a product is analogous to the sum and difference rules, so that FG product derivative is same as F prime G prime. This is not true. By using definition, let's try to find a derivative. We'll assume f and g are simultaneously differentiable. Then the product and a derivative of a product in definition is limit h approaches 0, and that is fg at x plus h, and that is fg at x divided by h. Now for this product, we are subtracting this blue term and now adding it. So same as earlier one. Now we'll reorganize it. So here gx plus h are common for these two terms, so that we can put it here now outside, and here for second part, here now f of x is common, so that we can put it outside. So they are the same. Okay, here we assumed in the beginning fg are differentiable, so that this limit should exist, and also of course g and f are continuous, so that the limit exists and fx is there, and also we assumed that here g is differentiable, so that every the limit we can find the limits, so that the limit can be applied to here the part by part. So this term is approaching to f prime. For that one, g of x. For fx, the same. And this final term is converging to g prime. So here, that will be the rule for product. Here, product rule is once fg are differentiable, then so is their product fg, and the derivative of fg is same as f prime g plus fg prime. So in alternative notation, we write down in this way, ignoring here now the variable x. Fg prime is same as f prime g plus fg prime. Or by using uv notation, derivative of uv is same as derivative of u times v plus u times derivative of v. Okay, let's try to find the derivative of the following functions. Okay, that is product, this term and that term. So you may think this first part is f, second part is g. Then now y prime equal same as f prime. So that is 8x and times g, which is 2x plus 5, and plus f, that is 4x squared plus 3, and g prime. Okay, from here, now x derivative is 1, so that 2 times 1 is 1, and that will disappear. So there's 2. You can simplify if you want. Now, for this one, and you may think this is f, that is g. That is f, and that is g. Then y prime is, okay, let's write down here f prime g plus f g prime. Okay, what is f prime? The same as e to the x. Derivative of e to the x is same as e to the x. So it's 4 e to the x and times g, x cubed plus 1 over x, and plus. Now f that is 4e to the x. And now we have to put here g prime, that is 3x together, and that is same as x to the minus 1, so that minus x to the minus 2. And you can simplify if you want. So the 4e to the x is common, and remaining terms are x cubed plus 1 over x, and that is now 3x squared, and minus x to the minus 2. Okay, that's the answer. Okay, now, and similarly to the product rule, and quotient rule can be proved, derived in this way. Here, f over g, this quotient, and if you are taking derivative, then on the bottom, that is g squared, and the top, f prime g minus f g prime. And ignoring x terms, we can write in this way. F of g prime is the same as f prime g minus f g prime over g squared. And similarly, for uv notation, you can write, say, in this way. Okay, let's try to find the derivative of these functions. Now, here, that top portion is f, and bottom is g. So here, capital G prime over x, that is same as, okay, here bottom is g squared, x plus 1 squared. Okay, top is f prime g, f prime, that is 24, x to the 3. Now, minus 5 derivative will be 0, and here times g, x plus 1, and minus top f, that is 6, x to the 4, minus 5, and here g prime, x plus 1, the derivative is 1. So if you want to, then you can simplify, but that is the answer. It can be an answer. You don't have to simplify. The simplification is a simple algebra. Okay. Now again, for this one, now top is f, bottom is g. Okay. So here y prime is the same as f prime g, f prime, but f, the derivative of e to the x is same as e to the x, so that 6 e to the x, that's f prime, and g is 1 plus e to the x minus. Now f is 6 e to the x, and here g prime, okay, 1 prime will be 0, but e to the x prime is e to the x, right? And bottom, okay, that is here, bottom must be g squared, so that 1 plus e to the x squared. Okay, we can easily simplify it. Okay, now here 6e to the x, that is the same as this one, so the remainder part is 6 e to the x alone remained, and the bottom is the same as 1 plus e to the x squared. That's the derivative. Okay. Okay, now for this capital F of x is defined in this way. So when you try to get derivative, then now you need f prime, so that you may start with f prime, the top derivative, that is 2x e to the x by using product rule, and plus here that is x squared and e to the x. E to the x is common, so that you can write down here that's 2x plus x squared and e to the x. You can write in this way, and then by using f prime, you can finish the derivative more conveniently. You can do it yourself. Okay. Okay. Now we'll consider the second and higher order derivatives. And once y equal fx is differentiable, then now the derivative f prime x is also a function. Now f prime may have a derivative, and then its derivative is f prime one more prime. So we can write down like this, double prime. So that is called second derivative of f. So here in notation we can write down f double prime at x, or d squared over dx, f and y, and like this d over dx and one more time of d over dx, or y double prime. Or we can write down this one in this way, d over dx. That is differentiation operator. So it's a square, and now y over f. You can write in this way. So in various way, we'll try to denote the derivative, but and we'll mostly use here double prime notation, and now d squared over dx squared. If y double prime is differentiable, then its derivative can be written in this way along with triple prime. So they're the same as, oh boy, that is now x is missing. That is dx cubed. D cubed divided by dx cubed and y. That is a third derivative of y. Okay. So here, okay, again, here missing x, and there's n. Okay. So there's a, and once in general power for integer, nth derivative usually we put inside of the parenthesis. So y to the n, y nth derivative is same as, so from y n minus first derivative, we do one more time of derivative, and that's in notation dn over dxn y, and that is now along with the differentiation operator d, we can write down dn and y. That is nth derivative of y with respect to x. Okay, here for this function, let's try to find f prime and f double prime, prime, and f triple prime. Okay, for f prime, okay, for this term, we may use product rule, so that 6 is constant, x derivative for this term is 1, and e to the x. Now plus, and okay, let's do it in this way. And then here x times the e to the x derivative is same as e to the x. Okay, now derivative of x squared is 2x, so that is a 4x. So we can rewrite this one in this way. Here 6 is there, and now x plus 1 e to the x minus 4x. Okay, now f double prime of x, that is, we'll try to make one more time of derivative for that one. That is same as 6 is there, and derivative of x plus 1 is 1. Now there is e to the x, and plus now 6. Okay, here that is x plus 1. You may think now product rule here, that term and that term, so that derivative of this term is same as 6 and e to the x here, and this term times derivative of e to the x, which is now e to the x. Now derivative of minus 4x is now minus 4. So we can rewrite this one in this way. That is here 6x plus 2 that is 2, and okay, x plus 2 and e to the x minus 4. Now for triple prime, okay, here again the derivative of this one is a 6 and e to the x plus that term 6x plus 2, and the derivative of e to the x is same as e to the x, and derivative of minus 4 will be 0. Now we can simplify that one in this way. There is a 6 and x plus 3 e to the x. Okay, that is the answer for triple prime, third derivative. Okay, find the equation of the tangent line to the curve at the given point. Okay, so here the point 1, 3 is given when x equals 1, y is 3. That is, a point is given, so we need the slope, that is point, and slope. Then by using point slope formula, we can get the tangent line. The slope can be found in this way from derivative. Okay, y prime equal 2 times x cubed is 3x squared, and minus x squared is 2x. And that derivative is now 0. So we can rewrite this one 6x squared minus 2x. Here when, so that y prime at x equal 1, that is 6 minus 2, which is 4. So we know that the slope is 4. So here the tangent line can be written in this way. Y minus y0 is 3 equal slope is 4 and x minus x0, which is 1. So you can rewrite, but that is the answer. Slope, point to slope form of the line. Okay. Now here we're going to find a tangent line at this point, x0, y equal 3. So we have to get y prime, and when x equals 0, we have to evaluate it. But here, in earlier problem, we found here the derivative, 6 e to the x divided by 1 plus e to the x, which is same as that one, 6 e to the x and 1 plus e to the x squared. So already we know the derivative, so which is same as 6 e to the x on the top and bottom, and 1 plus e to the x squared. When x equals 0, okay, that is here 6 times 1 divided by here e to the 0 is 1, 1 plus 1 squared. So it's 6 over 4, which is same as 3 over 2. Okay, we found the slope. So here the equation of the tangent line can be y minus y0, which is 3, and here the slope is 3 over 2, and x minus x0, which is 0. So you can simplify. Okay, finally, we'll try to find the points on the curve where the tangent line is horizontal, which means that tangent line is horizontal. That means here the derivative is 0, right? So that we have to find the point such that y prime x at x equals 0. We have to find the x satisfying this equation. Okay, let's here try to get y prime. That's 3x squared from the first term, and from the second term we have 3, minus 3. So we try to equalize it 0. Then now 3 x squared minus 1 equals 0. So here x is plus minus 1. At plus minus 1, the derivative is 0. And here, so that tangent line should be horizontal. So that is the final answer. Okay. This is the end of the section. Thank you.